Alright, so for this video, we'll be discussing the May-June 2025 paper 6.1 for probability and statistics 2. Okay, so let's continue. Let's start with our first question. Okay, so it is known that there's 1% of houses in a certain area have a wind turbine. Then there's a sample of 400 houses. Okay, in the area is chosen for a survey. The number of houses in the sample that have a wind turbine is denoted by the X. Alright, so use a suitable approximating distribution to find x smaller equals to 3. Okay, so there are one keyword here, there's a keyword here, approximating. That means originally it belongs to one distribution and we are going to change it to the other distribution. There are two approximation in A2 syllabus for stats 2. The first one will be, originally you are having Poisson distribution and you are changing it become normal. So that's the first type of distribution. And the condition to apply the distribution, to apply the approximation is when the lambda is more than 15 for the Poisson. The second type of approximation is originally you are having binomial distribution and after that you are changing it become Poisson. And then the lambda will be n times p. Then what's the condition for changing binomial become Poisson distribution? It is when your n is greater than 30, that's 50, sorry, is large. That's the first condition. Second condition is your n times p must be smaller than 5. Okay, if you have a look for this question here, we are having a large sample of 400 houses, and after that, there's only 1% of the houses have a wind turbine, and this 1% is actually the probability p. And if you try to double check and see, when you are having 400, and then we are interested to find out the probability of number of houses less than 3. So 400 is a large sample. We are interested to find out the probability for the number of houses less than 3 equals to that something happened. So this structure belongs to binomial distribution. Alright, so if you know that originally this is binomial distributed, then the n will be 400 and the p will be 0.01, 1%, right? And if you double check, you will see that basically if fulfill the condition that we have where n greater than 50 and p smaller than 5. Therefore, we are going to change become normal, we are going to change become Poisson. How to get the Poisson distribution here? The lambda, you are taking n multiply with the p. N multiply with p, you'll get a 4. So the lambda is equals to 4. Okay, then binomial belongs to discrete random variable. Continuous also belongs to discrete random variable. Therefore, continuity correction is not needed. We can directly find the probability for x smaller equals to 3. For a Poisson distribution, what is the general formula? To find the probability, when you're having x equals to r, the general formula will be e negative lambda power r divided by r factorial. And we are interested to find the probability for x smaller equals to 3. So that means you have to start from x equals to 0, x equals to 1, x equals to 2, and also x equals to 3. When you're having x equals to 0, it will be e negative lambda power 0 divided by 0 factorial, it is a 1. Then x equals to 1 is lambda power 1 divided by 1 factorial, it will be the lambda. Then when x equals to 2 will be lambda squared over 2 factorial. X equals to 3 will be lambda power 3 divided by 3 factorial. Okay, then try to just get an answer from the calculator. By right, you'll get the answer 0.433 correct to 3 significant figure. Alright, so this is how we answer question number 1. Question number 2. There's a random variable x with this distribution. Originally, it's binomially distributed. There's a random sample of 100 values of x is chosen and use the sample mean, and the sample mean is found. Then find the probability that sample mean greater than 6.2. You are not expected to use a continuity correction. So maybe you can highlight the x bar here, which is a sample mean. And this question belongs to sampling distribution. Alright, and you need to know that for calculation for any sampling distribution, because the sample size is large, here, n is large, right? Therefore, the sampling distribution will be approximately normal distributed, although the population is binomial. This is a population, okay? and how to get the mean and also the variance for sample mean. So you need to know that basically for the sample mean, the mean of the sample mean is the same as the population mean, which is mu or the n times p, because originally this is binomial, right? And for the variance, it will be npq divided by the sample size n. So you can see there are two n here, right? So to avoid confusing, usually I will put the sample size at ns, so divided by ns. And this one is the n, this one is the p. Okay? Yeah, then after that, we are using distribution to calculate the probability that they want us to find. And let us start. For binomial distribution, I want to calculate the mean first. What's the mean for the population? This one I call as population now, right? Then to calculate the mean, it will be n times p. So 8 multiplied with 3 over 4, and I will get 6. Okay, then after that, for the variance, for the population, I will be having n times p times q. And what is the answer here? I will be having 6 multiplied with 1 over 4. I'll be having 3 over 2. This is my variance. Then we are interested to find the sample mean, right? And we are going to get the sampling distribution for sample mean. It is normally distributed like what I told you just now, because the sample size is large. Therefore, it will be normal distributed. What's the mean for the sample mean? It is the same as the population, which is 6. What is the variance of a sample mean? So it will be the population variance 3 over 2 divided by the sample size. What is the sample size that what do I have here? 100. So for the mean, for the variance of a sampling mean, I will having 3 over 200. Okay, then now, if we already know the distribution of the sample mean, then we can start the calculation of the probability. So I'm interested to look for sample mean greater than 6.2. And since we know that it is normally distributed, so we have to change it become z. So I take the value of the sample mean minus, standardize it, so minus the mean, 6, divided by the standard deviation, so it will be square root 3 over 200. And you're having z greater than 1.633. Then we have to get the value from the normal distribution table, looking for 1.633. But the table will give us the probability for z smaller than 1.633. Okay, therefore to get the answer for greater than, you have to take 1 minus, right? Okay, then we look for the probability z smaller than 1.633. 1.6 is this one. 1.63 will be here. Then this is a 3. You can see from this part, 9484 plus 3 to the last digit, 9484 plus 3. So from here you have 9487. Okay, then this answer will be 0.9487. You have to take 1 minus 0.9487 because the table just now gives us the area smaller than, but we are looking for the area greater than. Therefore, I have to take 1 minus the answer from the table. Then, if you didn't do careless mistake, this is the answer that you should get. Alright, then just a reminder, in your step for writing out the solution, please make sure that you always show the step of standardization. Okay, then also please always keep your value of the z into 3 decimal places, because the accuracy for our table is up to 3 decimal places. Alright, so please make it up to 3 decimal places to get the most accurate answer. Then after that, only you can get the correct answer here. Okay, then let's continue to part B. Now they are asking you, state why the central limit theorem was needed in the calculation in part A. So basically, we did apply the central limit theorem in part A. Why? It is because of when the population is not normal. Okay, when the population is normal, then it is common that your sample mean is normal, right? Because population normal and sample mean you're taking out from the population. But if the population is not normal, like our example here is binomial, how can I say that the sample mean is normally distributed? The reason is because of we apply the central limit theorem, where the central limit theorem mentioned that if the sample size is large, which is more than 30, then basically the sample mean will be normally distributed. Okay, so you can see that here, although population is binomial, but I still assume that sample mean is normal. It is because of we have applied central limit theorem. Alright, yeah, so this is how we solve question number 2. Question number 3. We are given the time t minutes of a certain daily bus journey is normally distributed. Highlight the keyword normally distributed. The bus company claims that the mean is 45. But the passenger believes that the mean of t is actually greater than 45. She notes the time taken for the journey on random of 60 days. Then the results are summarized as below. So these are the details that I have. Okay, calculate the unbiased estimate of population mean and also the variance. Alright, so just to recall back, what is the formula for the unbiased estimates of population mean? I lazy to write so long, so I just write out the mean. But basically, it means that it is the unbiased estimates for the mean. We are estimating the mean, the population mean, by using the sample value. All these are coming from a sample of 60 days. Alright, and we are using it to estimate the value for the population mean. So the mean formula will be same as the sample mean. So it will be summation of t in this case divided by the n. And the unbiased estimated variance, population variance, the general formula, there are two. The first one is 1 over n minus 1, summation of t square, minus summation t then square over n. This is the first formula. Another formula is you can also have n divided by n minus 1, then the normal type of formula of variance that you calculate before, the population variance or the sample variance. So summation t square divided by n minus summation t over n squared. I think these both equations are basically provided in the formula booklet, so you can refer to it if let's say you can't remember. Alright, and later when I want to calculate the population variance, I will use the first one. Okay, so let us start. Now let us calculate the unbiased estimated value for the population mean. So what is the mean formula? I will be having 2750 divided by 60 is sample size, and I will get the value of 275 over 6. This is the mean. Then what is the variance? To calculate the variance, I'm using the first formula, right? So it will be 1 over n minus 1, where it will be having 1 over 59. Summation of t squared will be 127000 minus the t square, so 2750 square divided by n, which is 60. Okay, for this example, right, if I use this formula, the calculator will give me a long value, 16.24293,785. Then of course I can't keep my answer in this way, so I have to correct it to 3 significant figure where it should be 16.2. But you can see that in my solution here, I try to write out the whole value here, the long value here, because later in part B, right, actually I need to use back the value here. So I cannot use the shortened value, which is 16.2, but I have to keep it originally long one. And I believe that if you're trying to use the second formula, you might able to get the answer in the fraction form. That will be even better, right? Okay, so this is what you have for part A. The unbiased estimates for population mean and also the unbiased estimate for the population variance. Okay, then let us continue to part B. What do we have in part B? They want you to run a test for the passenger's belief at 5% significance level. Right. This question is normally distributed. Therefore, we know that we are going to test the population mean. What's the mean originally given in the question? We are having the mu is equal to 45 minutes, right? So 45 minutes. How can I set up the alternative hypothesis? It will give us some hint in the question. And then the keyword is this one, greater than 45, because the passenger suspect or believe that the mean is more than 45. So this will be our alternative hypothesis, where you will be having mu greater than 45 minutes. Alright, okay. Then since this is normally distributed, therefore, when I want to run the test, I will use the normal diagram to help me. Where is my rejection region? This is the right one tail test on the right. Therefore, my rejection region will be on the right. Where this particular area here is 5%, right? Here, 5%. So it will be equal to 0.05. The big area here will be 0.95. And first, I want to calculate, or I want to get the value for the critical value. Critical value. Okay, so how can I get this critical value? I can take it from the normal distribution table, looking for the big area 0.95. Okay, if you scroll down, looking for 0.95 here, you can see that your Z is 1.645. Therefore, your critical value will be 1.645. Alright, yeah, so this is my second step to find out the critical value. Next one, I want to calculate the test statistic. So how to get the test statistic? The general formula for test statistic will be okay, so the general formula for test statistic is this one. Because we are using the sample value to calculate, to run the test, right? So the standard dice formula will be sample mean minus the population mean divided by the population standard deviation over square root n. This is my test statistic formula and I want to calculate it now. Okay, what is my sample mean? Just now, we know that our sample mean is basically 275 over 6. Okay, so 275 over 6 minus the population mean that we want to test, which is 45. Okay, divided by standard deviation. The standard deviation, I have to use this value. I have to use this variance value. Okay, then I make it become the standard deviation. Okay, so the variance value, variance I have 16.2 lah. So I write out short, but when I press the calculator, I press a long value, yeah? Then divided by the n. What is the sample size? 60. Okay, so please take note that this is the unbiased estimated population variance. But I want to find out the standard deviation, therefore I have to square root it. When I square root it, when I write out the value here, you can see that I write out a short value 16.2. But I want to emphasize that when I press calculator, basically I'm pressing a long value. Okay, right. Then what's the value of the Z that we have here? By right, you should be getting 1.602. And this is my test statistic. Okay. Then next one, we are going to compare the value of test statistic and also the critical value. And from here, you know that your test statistic is basically 1.602. I put it here. 1.602, and it is smaller than the critical value. What's the value of critical value here? It will be 1.645, right? We have found out just now. And now I want to place my test statistic into the diagram that I draw. 1.602, very obvious, it is before the line of 1.645. And when you draw the line of 1.602, this blue color line falls under the white area here. The shaded area will be the rejection region. The white area here is the acceptance region. Therefore, you can make a conclusion from here, from the diagram. You know that it falls under the acceptance region, right? And we do not reject the null hypothesis. Okay, then after that, please make a conclusion in the context of the question. If you do not reject the null hypothesis, means that the passenger belief is not correct, right? So you can just tell them that there's insufficient evidence show that the mean of t is greater than 45. Okay, yeah, so this is what you need to show when you try to run the test for the mu. Okay, and this is how we solve question number 3. Question number 4. At an entertainment center, the cost for using a particular video game is 0.4 per minute. So the cost basically is depends on the time, yeah. The number of minutes for which the people use the video game has been 15 and also the variance 9. So this is the mean and also the variance for the minutes, the number of minutes. Find the mean and variance of the amount people pay for using the video game. Right, so first of all, you need to know that we are going to calculate the amount people pay, right, which is the cost, right? Okay, it will be 0.4 per minute. So if I want to calculate the amount that the people pay, I put it as A. It will be equals to 0.4 multiply with the time that you want to have. Correct? Okay, so that means amount paid will be 0.4 T. If I want to calculate the mean for the A, that means I'm having 0.4 multiply with the mean of the T. And just now we did given, we got the value for the mean of time, right? Which is 15. So I take 0.4 multiply with 15 and you will get the mean equals to 6. So the mean for amount to pay is $6. Should be that, right? Then after that, for variance, how can we get the variance for the A? Again, variance for the A means variance 0.4t. When you want to take out the 0.4 from the variance, you have to square the 0.4. And you're having 0.4 square multiplied with the variance of the t. Okay, then after that, what is the variance of the t that is given just now? Variance is 9. Then simplify it, you'll get 1.44. Then let's continue to part B. For each day, there are 35 people independently use the video game. Find the mean and variance of the total amount. Highlight the keyword for total amount paid by 35 people. Okay, so now if I want to get the total, so total I put it as, I cannot put T anymore because just now I have used the T, right? Okay, total amount paid, maybe I put it as X. So for total amount paid, you have to add up the amount paid by 35 people. So you have amount paid by people number 1, amount paid by the second person, amount paid by the third person, and so on until the 35%. So what I need to do so, it is a plus, it is because of they are talking about the word total. You add them together. Alright, so when you add them together, it has to add one by one for each of the people. So it should be A1 plus A2 plus A3 until A35. Then when you want to get the mean for the total amount paid, you'll be having EA1 plus EA2 until so on, until EA35. And basically it means that you're having 35 times of expected value of the A. What's the amount? The mean of the amount that we paid just now, yeah? That we calculate in part A. So the mean is 6 for each person. So you'll be having 35 multiplied with the 6. And from here, you get 210. Then how about for variance? For variance of the x, basically you need to have variance A1 plus variance A2 plus variance A3 until variance A35. Okay, then it means that you are having 35 times of the variance A. So 35 multiplied with the variance A. And what's the variance that you calculate in part A just now? It is actually 1.44, right? And now what do we have here is 50.4. Okay, so just in case, yeah, this is the answer. Just in case you are the students who are very confusing about when do I need to have the 35 with the square for the variance. So like this example, part A, we are having 0.4 square. But for part B, we don't have 35 square, we only have 35. So when do you need to apply square and when you no need to use the square here? And basically, I always mention in the, maybe in the video before, it depends on the question where you have to look for the meaning of the question. If they are talking about total, the summation, like this one, total amount. Total means that you have to add one by one. Therefore, the variance here, you also have to add one by one, where you have 35 times of the variance and there's no square. But when they are talking about multiplication of the variable. As an example, like 0.4 multiplied with the t. This is multiplication, not summation, right? So 0.4 multiplied with the t, when you want to take out the 0.4 from variance, then you have to square the constant term here. So that's the difference, all right? You basically have to look at the word provided in the question itself, right? So this is how we solve question number 4. Question number 5. We are having W and X, both are Poisson distributed. Then they want us to find the probability for this one. We're having W plus X. W is Poisson distributed, X is also Poisson distributed. Therefore, W plus X is also Poisson distributed. And you are just trying to add the mean together to get the new lambda. So the new lambda here will be 3.5. And we are interested to find the probability from 3 until 5. That means when your W plus X equals to 3, the formula is E negative lambda. Then you'll be having lambda power 3 divided by 3 factorial. Then W plus X equals to 4 will be lambda power 4 divided by 4 factorial. And also the W plus X equals to 5. So lambda power 5 divided by 5 factorial. Okay, so this is a formula for the Poisson distribution. Try to press calculator. Of course, you will get a very long value one. Okay, then please cut it short into 3 significant figures for your final answer. If by right, it should be 0.537. Right, yeah, so this is A1. Then let's continue to A2. We have a random variable S is the sum of 100 independent values of W and 200 independent values of the X. Use a suitable approximation to find S greater than 600. Okay, then how can we get this one? The keyword given here is approximation, yeah? Then originally W and X is Poisson distributed. And what kind of approximation do we have in our syllabus here from Poisson? Okay, so again, we are having Poisson distributed. If let's say I'm having the lambda, you can change it become normal. Then both mean and variance are lambda as well. And you can also only apply this when your lambda is more than 15. Okay, then let's have a look here. I'm having S, which is equals to 100 times of W. That means you have to highlight the keyword, not 100 times, it is sum of 100 W and also the sum of 200 X. Okay, so that means you have W1, W2, W3, W4 until W100. Alright, then when you add them together, what do you have here for the mean? Okay, so you should know that when W plus X something plus something, Poisson still remain as Poisson, right? Same thing happen here. If I add 100 W and also 200 of X together, it is still Poisson distributed. So how can I calculate the mean for the S here? It will be 1.2. You have 100, 1.2 plus 1.2 plus 1.2 for 100 times. So in short, it will be 1.2 times 100. Then the 2.3 also have 200 times, right? 200x, so you add 2.3 for 200 times. So in short, it will be 200 times 2.3. Then the total is 580. And the lambda is very big than the restriction here, right? Lambda greater than 15. Therefore, you can directly change it become normal distribution. Mean and also the variance are the same, which is equals to lambda. Okay, then after that, they want you to calculate the probability that the S is greater than 600. Okay, and now you have to have a look here. This is discrete random variable for Poisson. Normal distribution is continuous. Discrete random variable, when you want to change it become continuous, you have to do some adjustment to close the gap for the discrete random variable. So X greater than 600, before you calculate the probability, you have to apply continuity correction. So how to decide the value for continuity correction? Usually I will write a few value here. I have 599, 600, 601, 602, and also 603. When they say x greater than 600, that means when you want to calculate the probability, you should start from 601. Because originally, your S is Poisson distributed, right? Okay, so you want to calculate the probability from 601. How to, what's the value for the continuity correction? It should be slightly before the area that you want to find. So this is the value. And you can see that it is basically 600.5, right? Therefore, it will be S greater than 600.5. This is a continuity correction. Then after that, only you start standardizing the variable and found the probability. So why I standardize it? It is because of now the S is continuous is normally distributed. Before you can find the probability, you have to change it become Z first. So Z greater than, you take the value of the S minus the mean. So minus 580 divided by 580. Sorry, divided by square root of 580 because you are looking for standard deviation. Okay, then what is the value for the Z that I have? Okay, correct to 3 decimal places, it should be 0.851. Then again, I have to take 1 minus the area that I get or the probability that I get from the table to get the final answer. Because for table, they give us the value Z smaller than 0.851. Okay, looking for 0.851, 0.85 is this one, then 1 is 3. That means you have to take 8023, 8023, add the 3 at the last digit, so you'll be having 8026, right? Okay, then that means you have to take 1 minus 0.8, what's the value? 8026, yeah. Okay, then you'll get 0.1974. Then for me, I will of course correct it to 3 significant figure where you should be having 0.197. Yeah, then let's continue to part B. Okay, for part B, now they give us the random variable y, which is also Poisson distributed with the lambda as the mean. Okay, then they gave us this equation. By using this equation, you have to find the value of lambda. Alright, so let us start with the equation here first. 5 over 2 py equals to 3 plus py equals to 4 equals to py equals to 5. Then now please substitute in the equation, the formula for the Poisson distribution. Y equals to 3 means that E negative lambda, lambda power 3 divided by 3 factorial. Y equals to 4, E negative lambda, lambda power 4 divided by 4 factorial. Then E negative lambda, lambda power 5 divided by 5 factorial. Okay, so from here you can simplify all the E power negative lambda. Okay, then after that we simplify all the value here. By right, you will be having 5 over 12 lambda power 3, 1 over 24 lambda power 4, then 1 over 120 lambda power 5. If I try to reface it again by trying to keep all the terms at one side, this is what I have. Then if I want to simplify or solve for the value of lambda, I think I would prefer to get rid of the denominator. I don't want to have all the denominator here. Therefore, I multiply the whole equation by using 120. If I multiply it by using 120, I will have this equation, lambda power 5 minus 5 lambda power 4, then minus 50 lambda power 3. Okay, then how can I further solving this equation here? I can factorize out the lambda square, or lambda cube, sorry. Then it will become lambda square minus 5 lambda, then minus 50. Then from here, I can easily factorize it. So lambda power 3. Then I factorize it, I will have negative 10, then plus 5. Okay, it becomes negative 5, right? Yeah, then I will have lambda equals to 0, lambda equals to 10, then lambda equals to negative 5. then these two values we have to ignore it. We only accept the value where lambda is equals to 10. Okay, so why? You maybe can read the question one more time. Okay, they did actually mention in the question that the lambda should be greater than 0. That means a positive value. Therefore, this is the only answer that we should accept. Question number 6. There's a manufacturer of cell phones claims that 25% students owns a pumpkin phone. Then Jiraj thinks that the proportion of students at his large college who own a pumpkin phone is less than 25%. He plans to test the manufacturer's claim. So plan to test, yeah. Okay, so the word less than 25%, the keyword less than might be the keyword to help you and set up the alternative hypothesis, right? He chose a random sample of 30 students in his college. If the number of students who own a pumpkin phone is less than 5, then he will reject the manufacturer's claim. State a suitable hypothesis for the test. Alright, so let us set up the hypothesis for the test first. What is the null hypothesis? They are talking about the percentage, so we are going to test the population proportion. Therefore, P is equals to 0.25 for null hypothesis. For the alternative hypothesis, like what I told you just now, the keyword is actually less than 25%. So when you want to set the alternative hypothesis, the P will be less than 0.25. Okay, then after that, this is what we have the hypothesis now, and also the alternative hypothesis. So which one is the manufacturer's claim? This is the manufacturer's claim, right? Okay, then this is the students, the Jayraj's claim, right? And this is what we have for part A. Then let's have a look for part number B. Given that the true proportion of the students at the college who own a pumpkin phone is actually 10%, use a binomial distribution to find the probability of type 2 error. Okay, so for this question, they are talking about type 2 error. Let us write out the definition for type 2 error first. What's the type 2 error definition? So by right, it should be accept null hypothesis when the null hypothesis is false. You are accepting something which is false, therefore you make a type 2 error. Alright, to calculate the probability, accept null hypothesis means that you need to put acceptance region here. Okay, but where to get the acceptance region? We have to read the question one more time and see whether is acceptance region or rejection region is given. Let's go back to the question again. Now they say if the number of students who own a pumpkin phone is less than 5, this particular sentence tells us that if x is less than 5, then Jayraj will reject manufacturer's claim. When they said reject manufacturer's claim, means that they reject the null hypothesis. So x smaller than 5, we will reject the null hypothesis. Okay, so what's the meaning for x smaller than 5 here? Basically, it is the rejection region. Because when x is having this smaller than 5, then you'll reject, right? So we call this as rejection region, x smaller than 5. But in our part 2 calculation, we need acceptance region, right? So it will be the opposite of the rejection region, which is x is greater or equals than 5. Rejection region has no equal sign, therefore your acceptance region should have the equal sign. Okay, then after that, let us continue further. They say null hypothesis is false. Null hypothesis is false means that P cannot be equal to 0.25 because this is false. By right, it should be P smaller than 0.25, right? But P smaller than 0.25, there are many possible values that I can use, right? Therefore, in the question, they will give us a value to be used in the calculation. So they say the true value of the P is 10%. You can see that the 10% basically belongs to the less than 25% one, okay? So this is the new P that they give us. That means I'm having P equals to 0.10. Alright, then to calculate this probability, you might need to write out the distribution. They said I have to use binomial distribution to find the probability. What is the sample size that I have here? they are using a sample of 30 students, right? So you're having 30 students and the probability is 0.1. Okay, then I'm interested to find the probability of x greater equals to 5. That means you can start from 5, x equals to 5, x equals to 6, x equals to 7, and x equals to 30, which is very long, right? Then I have to take 1 minus 0, 1, 2, 3, 4. Okay, so we start. X equals to 0 is 30C0, 0.1 power 0, 0.9 power 30. Then minus 30C1. Okay, when x equals to 1. Okay, then 0.1 power 1, 0.9 power 29. Then 30C2 when x is equals to 2. Then x equals to 3. And also x equals to 4. Okay, then maybe you need to spend a little bit of time pressing the calculator. Make sure you don't do any careless mistake. By right, you will get a long value lah. Then of course, I will cut it short, correct to 3 significant figure. So this is what I have for 6B. Right, then let's continue further. For part C. Okay, for part C, now at Florence College, there's a random sample of 40 students. Found that 5 owns a pumpkin phone. They want us to calculate 95% of confidence interval for proportion. Right. Okay, then again, let us start to write out the general formula for confidence interval of population proportion. So what is it? So it should be P, then minus Z, square root PQ over N. Where P is a success rate, okay, or maybe the people who own a pumpkin phone, then Q is the people who don't own a pumpkin phone. Then P plus Z square root PQ over N. Okay, so first of all, let's find out the success rate. First of all, the rate that people who own the pumpkin phone, it will be 5 out of 40. And this one, you should know that it is 1 over 8. If let's say P is 1 over 8, then what happened to the Q? The Q should be 1 minus 1 over 8, right? And it should be 7 over 8. What else do I need in our calculation here? You need the N. N, you'll know that it is 40. And another value that I need is the Z. How to find the value of the Z? You might need to use a diagram to help you a little bit. When I'm having a confidence interval, right? The 95% basically means that it is the 0.95% in the center, right? Then this will be the value of the Z, and this is the value for negative Z. To get the value of the Z, what I want to do is like, I try to write out all the area first. This is how our area looks like lah. Okay, 95% means 95% in the center. So divide 5% equally to left and right hand side. So each side will be having 0.025. To get the value of the Z, I have to refer to this big area here, 0.975. This blue color area. So these two areas adding together, you'll get 0.975, right? Please look for the value of Z at the area of 0.975. Then again, go to table, look for the bottom part here. Okay, wait. Yeah. So is there any 0.975? You can see that the value of Z is 1.96, right? Yeah. Then our Z here would be 1.96. So this Z would be 1.96. Okay, so seems like we have get all the value that we want, and we can apply it in our formula to calculate the confidence interval. Right, so let's start here. 95% confidence interval basically is P 1 over 8 minus Z square root PQ over N. P is 1 over 8, Q is 7 over 8, N is actually 40. Then 1 over 8 plus 1.96 square root PQ over N. Okay, then after that, try to press the calculator a little bit. Again, for me, I will keep my answer correct to 3 significant figure because when you press the calculator, you should get a long list of value, a long value, right? So I cut it short into 3 significant figure, and this is what I get for the lower limit, and I will get my upper limit equals to 0.227. Okay, so this is how we solve question number. Okay, then we are now at question number 7, the very last question for this paper. We are given a PDF for the random variable x, then this is the definition for the function here. Okay, they want us to show that the probability of x smaller than half equals to this answer. To get the probability in the continuous random variable, you have to apply integration. Okay, so I have to integrate the function that I have here from the lowest limit, which is the 0. Then we want to look for the probability until half, right? So the upper limit will be the half here. Then integrate the function 1 plus cos pi x. Okay, integrate 1, you'll get x. It's a very straightforward term. What do I get if I want to integrate cos pi x? Okay, so just a recall. If I want to integrate cos mx, okay, basically what do I get here is sine mx. Because when you differentiate the sine, you get a cos, right? So you do it the opposite way. Integrate cos, you'll have the sine. For the sine, for differentiation, you multiply with the m. Because you differentiate the bracket, then you get an m, right? Then you multiply with the m. But for integration, you do it the other way around when you have to divide it by the m. Then there's a plus c at the back, lah, if you want to have a constant term at the back. Okay, then for this one, I'm having cos pi x. Therefore, after the integration, I'll be having sine pi x divided by pi. And I have to substitute in the limit of half and also 0. Okay, so let's see what do I have here. I'm having half plus 1 over pi. Substitute half into your x, you'll be having pi over 2. Then minus, substitute 0, then you're having 1 over pi sine 0. Okay, so 0 and sine 0 all 0 lah. What's the value for sine pi over 2? Sine pi over 2 basically is a 1, right? Therefore, when you simplify the answer, this is what you get. Half plus 1 over pi. And it is exactly the correct answer as what they want us to show. This one. Alright? Yeah. Then let's continue to part B. For part B, they want us to find out the expected value of the x, and they want us to show that this is the answer. Okay, then expected value of the x, generally you have to integrate x multiply with the function before you start the integration process. Okay, so same thing happened here. I'm having ex where I need to integrate x multiply with the function that I have. The function that I have is 1 plus cos pi x. Okay, then what's the limit here? My limit defined is 0 until 1, therefore I have to integrate lower and upper limit. Okay, 0 to 1, then dx. Okay, then now for this integration, you have to multiply the x inside first, inside the bracket. And from here, you are having the x, then plus x cos pi x. Okay, try to have a look for the x here. It is no problem for us to integrate it, but there's a big problem for us to integrate this one because you're having x multiplied with cos pi x. It is a product of two different functions, and when you want to apply integration on it, basically you have to apply integration by part. Okay, so what is the integration by part? It is actually one of the techniques that we learn in A2 Pure Maths, right? Okay. The general formula is if I want to integrate u dv, then the formula is uv minus v du. And the right hand side is the question. We separate our left hand side. Left hand side is the question. We separate our left hand side into two parts. One part is the u, another part is the integration of dv. Okay. Then to decide which is the u and which is the integration of dv, you have to apply the Liat rule, Liate, where L is log logarithmic function. I is inverse trigo. A is algebra. T is trigo. Then E is exponential function. When you're having the group that belongs to the higher group, then we'll put it as the U. When you're having the group at the lower group, then you'll put it as the integration of dv. Okay, so basically we want to apply it in our second term here, x cos pi x. Alright, so x belongs to algebra, cos belongs to trigo. So algebra is higher than trigo, right? Therefore, your u should be equals to the x. Integrate of dv should be equals to integrate cos pi x dx. Okay, for the u part here, you try to differentiate it. Therefore, du over dx, you get a 1. And your du basically is equals to dx. For this part, you have to integrate both sides. So integrate 1 dv, you're having a v. Integrate cos pi x, you'll be having sine pi x over pi. Okay, so for here, I don't put any plus c because our integration haven't completed yet. You have to continue with the formula and so on to complete it. Right, so I only put the constant term at the very last step of integration. Okay, and this is what we have for the integration by part here. And now I want to apply it in the step. Okay, so let's integrate x. I will be having x squared over 2. Plus, I copy a plus. Okay, then for this one is integration by part. This is the left hand side here. Then the right hand side is uv. What is the u? U is the x, v is this one. So you take in uv first. So x sine pi over pi x divided by the pi. This is uv. So uv, you put in the limit 1 and 0 also. Minus, copy the minus. Then v du. This is your v. Sine pi x over pi with the dx with the limit 0, 1 still. Okay, and now next one, what do I get here? Substitute 1 into your equation. You're having 1 square over 2 minus 0 square over 2. Okay, then plus, for this one, you'll be having 1 sine pi over pi minus 0 sine 0 over pi. Then how about the last term here? So for the last term, now you want to integrate it. The 1 over pi is a constant, right? So I just copy. What's a general formula for you to integrate sine mx? So just a small recall, integrate sine mx, you should have negative cos mx over m. Because differential cos, you have negative sign, right? But you're having a positive sign here, which means that the answer here should be, after the integration, is negative cos, okay? The negative is here at the cos part, right? So integrate sine pi x, you'll be having negative cos pi x over pi. Again, with the limit of 1 and 0. Then now we slowly simplify our answer here. This one, I will be having half only. This term, sine pi is a 0. 0 multiply anything, also 0. There's nothing here. Then for this part now, I try to take out all the constants. So I'm having 1 over pi squared, positive. I want to substitute 0 and 1 into my cos pi x. Cos pi x, substitute 1, you'll be having cos pi. Substitute 0, you'll be having 0. What's the value for cos pi? Yeah? Okay, so for cos pi, you will be getting negative 1. Then minus cos 0, you're having a positive 1. So minus 1, you get negative 2. And multiply together with the 1 over pi square, you will be having negative 2 over pi square. So let's double check and see whether is the answer correct. Oh yeah, so it is half minus 2 over pi square. And this is how we get the mean for the function here. Okay, so for this particular question, it is a bit tedious because of the integration by part lah. So you have to revise again from your pure maths part. Okay, how to apply integration by part correctly. Okay, yeah, so this is how we solve question number 7, and this is the end of the video. Thank you very much for watching this video.